Hi class, how you doing? Mr. Wallington. Welcome to week two of CIS 225. We are just progressing right along. Look like everybody had a pretty good week one, and hopefully we'll just glide right into week two. Now what am I gonna cover today? Well, we're gonna walk through our graded practice 2.10. We're gonna take the network we had last week and we're gonna add a second building to that network. So let's take a quick look at the overview. What is we doing? What are we going to do? Like I say, we're going to add a second building to our week one network. We're going to build the network. We're going to add 2 more routers. We're going to add switches, 4 switches. Going to have a server as well as 3 PCs. And we're going to configure the routers and the PCs so they can all communicate with each other. Give you an idea of what that's going to look like. If you remember from last week, excuse me, we just had this bottom building. It's this one network, okay? And now we're going to add to that a second building with 2 routers. Now the thing we're going to do differently this week, couple of things we're going to do differently this week. One, now we have to get routers to talk to each other, which means that we're going to have to talk about routing, static routes, and how to make the routers talk. Something else we're going to open up this week is VLSM, variable length subnet masking. Now the first week, last week we just did basically what I call static subnetting, where we divided everything up equally. We're going to do that a little bit differently, and because of that, you're going to have to re-subnet, excuse me, your network. Okay, let's get into this, okay? So first, let's do a quick overview of subnetting. Excuse me, boy, I got a little tickle there. I don't know why. All right, so if you remember from last, oh, yes, we have water. I love how that magically appears in video. Only in video can you make that happen. Watch this, it'll magically disappear. All right, so you remember last week, right? We talked about subnetting with our bingo analogy, okay? And with this bingo analogy, we had 256 chairs, and you know what bingo, you have to have that card caller, card checker. Those were the 2 seats that we couldn't sell, so we only have 254 available. If we wanted to divide that up, you know, we were dividing it up equally. We could split it in half, right, and have 128, 128, or we could divide it in 4 ways, 64, 64, 64, 64. That's how we subnetted last week, if you remember, right? Now, what's the problem? What the problem is, here's the problem, okay? You end up wasting a lot of seats when you do it this way, especially if you have rooms that need less than 62, way less. So you have a lot of wasted spaces, or in our case, IP addresses. This is where VLSM, variable length subnet masking, comes into play, okay? Now, what do we do with VLSM, okay? So what we're going to do, we're going to take the same bingo room and we're going to populate it, but we're going to have variable sized rooms. They're not going to all be the same increment size. So let's say we had a room and you want one large room that's going to have 126 chairs in it, okay? So what I can do, I can split that right in half and put 128 chairs. And again, that first and the last subnet ID and the broadcast, if you're talking IP addresses, can't be used. So that's 126 usable seats. Now let's say I want a second room that has 62 chairs. So now you see I can divide it again, but instead of having 128 and 128, now I can have another subnet or another smaller room with 62 chairs. Let's say if I needed a third room that had 30, or I needed 30 usable seats, I can keep subnetting with variable lengths. At the end, let's say if I just wanted a really small room that just had 2 chairs in it, okay? That's for the high dollar rollers in bingo. But I can continue to do that. So now you see I have variable length subnets. And it also allows me to have expansion. So if I added all these chairs up, the 128, 64, 32, 4, you see that's going to leave me that I still have 28 chairs available for future expansion. That is how variable length subnet masking works. Now, let's do the same thing, but we're going to use IP addresses instead of a bingo hall. All right, so we get an IP address, the same one we used last week, 192.168.10.0 with a CIDR of 24. That's a subnet mask of 255.255.255.0. Now, Here's my handy dandy table that I like to use. This is the mask. This is the bit or the CIDR. You know, it's 25, 26, all the way to 32 for the whole 32 bits of a IPv4 address. How many hosts that it can will provide at each of these increments, how many subnets you can get, and where it increments at, okay? That's the same table we used last week, nothing new here. Now, let's say that we have a network that has 5 subnets, and each of these subnets have a different requirement. Subnet 1 needs 20 IP addresses, Subnet 2 needs 10 IP addresses, Subnet 3 needs 20, Subnet 4 needs 10, and Subnet 5 needs 2 IP addresses. So this is how we would start the subnet. So let's take a look at this first subnet, right? I need 20 IP addresses. Where on my chart can I get as close as I can to 20, but I can't be under, and I don't want to go way over. So as close as I can get would be right here, right? 30, okay? Which would be a CIDR of 27. So that's where I'm going to do my first subnet at. I'm going to borrow these 2 bits, and that'll give me a CIDR 27, or a subnet mask of .224. That gives me 30 IP addresses, okay? That is as close as I can get. I can't go back to 16 because that would only give me 14. I needed 20. So that's going to be my first variable length subnet, all right? So now let's take a look at how that breaks out. So that first subnet, I need 20. So my subnet ID is going to be 192.168.10.0, which is, you know, my first subnet. I'm starting with my IP address that I was given. As always, the first host that I can use is not 0. It's going to be the 1. I can't assign the subnet ID. So the first assignable host is going to be 1. The last assignable host is going to be what? 30. And then the broadcast is 31. The CIDR is 27. See, it comes right off my chart. How many hosts did I need? I needed 20. How many do I have? 30. I'm good to go. So I've really only kind of wasted 10 subnets in this, 10 IP addresses within this particular subnet. Now, what is that going to look like? So my subnet, my IP address is going to be, for this first subnet, 192.168.10.0 CIDR 27. The subnet mask, 255.255.255. What? 254. Came right off my chart right there, 254. That is my first subnet. Now, what you're going to see happen here differently is that, you know, last week the subnet mask stayed the same, .128. This time the subnet mask is going to change. Why? Because we're doing different, we're doing a variable subnet length. So we look at subnet number 2, right? I need how many? 10 IP addresses. To get 10 IP addresses, what's the closest I can get to that? Would be right here of a CIDR of 28, which gives me 16 available hosts. Subtract the 2 from that, that's 14. So I need 10, that gives me 14. And we look at that second subnet. Now, this is where sometimes people get a little bit confused, but it's not hard. All you gotta do is just follow the math, right? My first subnet, if you notice, the broadcast address was 31, right? 192.168.10.131. Well, that's where my second subnet is going to start. So the subnet ID for the second subnet is going to be the next IP address after the broadcast for the previous. So it's going to be 192.168.10.32. That is the subnet ID for the second subnet. And now, for this one, I've got 16 total IP addresses, right? I can't assign .32. Cannot assign that one. It's the subnet ID. First assignable host is going to be .33. The last assignable host is going to be .46. And the broadcast is .47. Okay? So, and the CIDR, if you look at the CIDR, if you remember the CIDR on this one over here, it's going to be a .240. CIDR is 28, which gives you a subnet mask of .240 or .240. So you see my CIDR changed as well as my subnet mask changed. So the subnet ID, so the IP address for the second subnet is going to be 192.168.10.32 CIDR 28. The subnet mask 255.255.255.240. All right, so that's 2 subnets that we've built. My next one is going to be, if I continue down this path, right? Subnet 3, I needed 20 more IP addresses. Well, it's going to be just like this one again. CIDR 27. That's going to give me 20 IP addresses. The difference, though, is where I'm going to start from. See, I've already used all the way up to 47, right? All the way up to dot 47. So where does my subnet ID start for this one? You got it. If you said 48, you were 100% correct. If you said anything except 48, you were 100% wrong. So I just don't know which side of the aisle you're on. All right, so yes, it's going to be 192.168.10.48. That's the subnet ID for that third subnet. And then when I look at the first assignable host, 49. The last assignable host is going to be 78. The broadcast address, .79. CIDR, again, is going to be 27. And the subnet mask is going to be 255.255.255. Yes, someone in Virginia just said the right answer. .224. Let's take a look at that fourth subnet. If you notice, I needed 10 for it. It's going to also use the .240 or CIDR 28. Where do I start? 192.168.10.80 is going to be the subnet ID. And when I look at the assignables, 81 to 94, broadcast is 95, and it continues the same, right? CIDR 28, IP subnet mask 255.255.255.240. Now let's take a look at this last subnet. I only need 2, right? I only need 2 hosts in this last subnet, subnet 5. So where do I have to subnet to get 2 hosts? Give you a minute to look at the chart. Exactly. So I am going to subnet right here at CIDR 30. CIDR 30 gives me 4 total hosts. I can only use 2 because the broadcast and the subnet ID cannot use. So that gives me 2 IP addresses. How many did I need? I needed 2. And when we build that one out, you see the same thing. Now, here's what I'm going to do. Like I say, no, you would probably say, well, why did I just start at 96, right? And this is just a best practice. Best practice, as well as this is how the assignment is set up. For this particular one, we're going to talk about a little bit more in detail, but these are going to be the subnets for our routers. So what we did, we just kind of pushed those back to the end, start at 200. Why? Because that gives us a lot of expansion room if we need to add additional subnets in the middle. And also, as a network engineer, I can quickly look at this, and if it's a .200 IP address, I know that that is a router-to-router interface IP address. So that's why we skipped to 200 down here. So 192.168.10.200. That's going to be the subnet ID for this 5th subnet. Now the first assignable is going to be 201, the last assignable 202, and the broadcast 203 with a CIDR of 30. I needed 2 hosts. I have got 2 hosts. So the 2 assignable is going to be 192.168.10.201 and .202. And now we see how those lay out and break out. And the subnet mask, what's the subnet mask for this one? You've got it, .252. Okay, so that is how we can break up our, do subnetting with variable length subnet masking. And we've got our subnets that are more efficiently using the IP addresses and the IP address schemas. So let's talk about building the network. So this is what your network is going to look like, right? This was last week's. You're going to build basically the same thing on top of it, but you're going to add a serial to serial interface connection between the 2 routers. Okay. Now let's talk about how we actually build the network based on how we just got through subnetting. So if I look at my layout, okay, I've got 2 routers, router 1, router 2. I have 3 PCs, and I have a server. So using our IP addresses that we had, router 1, I'm going to give it the first subnet, 192.168.10.0, right? And for the executive network on router 1, I'm going to give it the 32 network. For the help desk subnet, it's going to get the .48 subnet. And for the engineering, we're going to give it the .80 subnet. And for this connection from router to router, that's where we give it we're going to use the .200 subnet. So that's how we're going to lay out those 5 subnets that we just completed on the previous slide here. So that's how we're going to assign subnets. Once we assign those IP addresses to subnets, now we can actually start assigning IP address to devices. So like I say subnet 1, like I said, what I'm going to do, like subnet 1, which is the executive subnet, we're going to give the router interface, the 000 interface, and we're going to go to a packet tracer here in a second, kind of walk through that. But we're going to give that interface the first assignable IP address, 192.168.10.1. And if you remember the subnet mask for that is .224.255.255.224. So that's going to get the first assignable. Now the PC, this PC out here, we're going to give it the next IP address, 192.168.10.2, and with the same subnet mask. So now we've just taken this first subnet and we've assigned the IP addresses. The first one went to the interface on the router, the gigabit internet interface on the router. The second IP assignable, which is .2, went to the PC. And if you notice, I tried to color code these, it's blue to blue. Is that fuchsia? I don't know, fuchsia. Okay, let's call it fuchsia. That's a nice term. Fuchsia to fuchsia. Looks purple to me. But anyway, so now let's look at the second subnet. We're going to do the same thing. We're going to assign IP addresses to each interface and to each device or each host. So on this one, like I say, the same router, but it's the other interface. It's the gigabit 001 interface. On the other side, I'm going to give it the first IP address of .33, because remember, this is on the 192.168.10.32 subnet. So the first assignable was 33, right? So that's why I'm going to give this interface 33. This PC, give it the next IP address of 34. Now each one of those, again, the subnet masks are going to be the .240 subnet mask for this subnet. All right, looking at our next subnet, which is this beautiful canary yellow. So if we look at, now this is on router 1, router 2, I'm sorry. If we look at router 2, so we see that I'm going to give that router 2 the gigabit internet interface 0/0/0, the first assignable of the .48 host subnet. So the first assignable is going to be what? 49, right? So that interface gets 49. That PC, you guys should see the pattern by now. Yeah, it's going to get 50. And the fourth subnet, which is going to be the other interface on that router, the second interface, the 0/0/1 interface, right? It is going to get the 81 and the PC 82. So I've taken my subnets, I've assigned each of the subnets to their respective subnets, the IP addresses rather, and I continue to assign that. Am I finished? No, remember there's one more subnet we have here, and that is this subnet from your router to router. Now, before you can make this connection, there are some changes you have to make to the router. There's a card, the NIM card that you've got, -T card, that you have to install in that router, in both of these routers, so that you will have a serial interface. Big difference between serial interfaces that connects routers to routers and Ethernet interfaces that connects networks to routers, subnets to routers. So this is the S serial interfaces on the routers. We're going to connect, because to get these networks to talk to each other, they have to go through that router. So this is where I'm going to take the .200 subnet and assign these two IP addresses. So my router 1 serial 0/1/0 interface, I'm going to give it the .201 address, and on the next other router, router 2, I'm going to give it the 0/1/1 interface, the 202 IP address. So this is how I'm going to assign IP addresses. for each of the different components. Okay, here's what we're going to do. We're going to go to Packet Tracer, and we're just going to take a look at these things. Now, I'm not going to build the whole thing in Packet Tracer for you, but we're just going to go to Packet Tracer so I can kind of show you, give you a visual example of some of these things. So when we look at Packet Tracer, this is what your network should look like, right? So like I say, you've got two routers, you've got your 4 separate subnets, and then the 5th subnet here is in the middle. So let's take a look at this router. So when we look at, as we look at this router and we look at the interfaces on this router, like I said, one of the first things we have to do is install this card, this NIM2 card. Now I've already installed it. The thing you gotta remember, always turn power off, just grab that, you're gonna drag it and drop it right into that, as well as this cover plate that you're gonna put, this NIM cover plate that's gonna fit over that blank space. So that's the first thing, and power it back up and wait for a few seconds for it to reboot. So that's the first thing you're going to do. Now when you look at this particular router, and if I just scroll over this router, now you see it shows me that my gigabit internet, because I've already configured this router, right? My gigabit internet interface is on the 000 is 10.1, and on gigabit interface 001 it is on .33 and continues right down the line. One of the things that you do want to do, I think I just saw a mistake on there, but I'll go back and catch that up later. One of the things that you also want to be able to do with in this environment is we'll have to add a route. Okay, and we're going to talk a little bit more about routes here as we go. I'm just checking my addresses here. Yep, there we go. Let's change that to, it should be .224. Somehow or another I fat fingered that and it was 248. All right, good deal. So one of the first things I want to do is I'm going to go into this router and we're going to take a look at, if I can type today, and we're going to take a look at the running configuration. Show run. So now you see that how my my router is configured. Don't worry about that IPv6 address. I was playing around with something else, and before this video, I said I'll just kind of play around with my IPv6. There will be a time in this class that you will install an IPv6 address on these interfaces. So this is what your interfaces should look like, minus the IPv6 address, is your IP address that's loaded on each interface, as well as the IP address that's loaded on the serial interface that connects everything together. Something else you're going to see in this environment is right there. This is a static route. IP route 0.0.0.0 space. There's a space there. Don't forget to put the space. I know it looks like you might not see a space. 0.0.0.0, and it's on serial interface 0/1/0, this router. What is this doing? This is allowing any IP address, this is all 4 octaves of your IP address, as well as all 4 octaves of the subnet mask, to be able to communicate between router 1 to router 2. So we've set up a static route on this router so that this router can talk to the other router. So that's very important, that if you don't have a route set up between your routers, you will not be able to communicate. Okay, so it's extremely important that we set up these routes properly. So that gives you just an idea of what the your packet tracer is going to look like. Now again, why do you need these routes in here? If PC1 on subnet 1 wants to talk to this server, how does it get there? How does it know how to get there? Well, this is what happens. And this is why it's important to know the local and connected routes on the router. Well, PC1 says, hey, look, I want to send a packet to the server. What it's going to do, and even if it knows the IP address of the server, which is what, .180.81. So what it's going to do is say, hey, look, I have a packet that needs to go. So it's going to find the default gateway. Now, the default gateway, and this is why we put the default gateway into this environment, so that PC1 always knows to go to the interface on this router. So the PC1, which is 192.168.10.1.2, is going to send it to the .1 interface. Now on this, and it says that I want to send this to the .180.81 IP address, which is here. Well, this router, since it has a connected route, knows that it's going to go, everything, all the traffic here is going to go to this direction, hit this router. This router, once it sees it, says, oh, .81. I know exactly where to send it, because it knows that the interface on this interface is the .80. So that means that all the traffic for that .80 subnet is going to have to go out this interface, and it sends it out. So this is how this PC is able to talk to this router, because these two routers, they know how to talk to each other. So that's why it's actually extremely important to have that those interfaces done properly. So like I say, let's talk a little bit more about, like I say, static routes. So like I say, a router learns about remote networks in two ways. It can be a static route, and that's what I just showed you. And thing with static routes, you have to manually load those routes in. This is what we're going to use for this week and next week. Now going ahead, we're going to start talking dynamic routes. We're going to use a dynamic route called EIGRP, Enhanced Intergateway Routing Protocol. This protocol is able to talk and learn routes dynamically, automatically, which is a great thing if you are a router. So now let's kind of use this as a backdrop, as an example. I basically took the same network and just turned it around, just made it easier and to be able to look at real estate a little bit better with in this configuration. So when I look at, and this basically what I did, I went in and I pulled the routing table for this router. You know, I loaded in. This gives you an idea of how to load in the route. Basically, once you get to the config, config T in the configuration mode, you're going to put IP route 0.0.0.0 space 0.0.0.0. Tell it the interface. In this case, it was serial 0/1/0. And when I hit that loaded that route. And it also said it made that gateway the route of last resort. So that way, any traffic going to that router, it knows this is where it's going to send it to. So now you see these are and we talked about these last week, the connected routes, local routes. This gives you an idea what that routing table looked like. But you look all the way down at the bottom, you see an S. And when you see that S, that means that is a static route. A static route. Like I said, later on in the week, later on in the course, we're going to talk about where you're going to see a D in here. And that D is for dynamic routes. So this shows us that we have properly loaded the static route into our router. Very important to understand static routing. All right. I covered quite a bit of information today, but this should definitely get you started on your week 2 guided practice. Now, if you do your guided practice properly, you feel comfortable with that, then you should be able to move into the project. I think it's 2.11, which is your project for this week, because what we're going to do every week, your guided practice sets you up for success for the project, for that phase of the project. So if you don't feel comfortable with the guided practice, you're probably not ready to move into the project, okay? Anyway, but if you have questions, by all means, reach out, contact us. We're online Monday nights at 8 o'clock Eastern Standard Time, where we do lecture, but I always take questions, as well as on Thursdays, 8 o'clock p.m., that's p.m., Eastern Standard Time, and that is strictly a Q&A session. So if you have questions, pop in, we'll try to answer. You can always reach out via email, via text, and we'll try to get an answer back to you. All right, have a great week too.